All right, what's going on, y'all? Mr. Love here. So today we're going to take a look at this calculus problem. This was a problem that I got from a post from Math Scribble. Shout out to you, bro, for this dope problem. So we're going to give it a go today. So it says let y be a function that has a domain of all real numbers and has a range of 0 to infinity. And it is the solution to this differential equation here, with the initial condition y of 0 equals 1 divided by the square root of 2. What is the value of y of log base e of 2? All right, so the first thing that we have here is a differential equation. And usually in a Calc 1 or 2 course, in order to solve a differential equation, you have to separate the variables. So there are 4 steps to separating variables. The first step is to, obviously separate the variables. Then we want to integrate both sides. Then we want to use, if we have an initial condition, use that initial condition to solve for the value of c. And then use that to ultimately solve for y. So that's what we're going to do here. So I'm going to first try to separate the variables. Now I'm going to rewrite my equation. Now as I'm rewriting, I'm going to notice here that I can actually factor out a y cubed from the numerator. So my numerator is going to be y cubed times e to the 5x plus 1. And in the denominator, I can factor out e to the x from both of these terms. I'm going to have e to the x times 1 plus y to the 4th. So my goal is to separate and to get all of the y's and dy's on one side and the x's and dx's on the other side. So since my dy's are on the left side here, I'm going to move all my y terms to the left. So that means that this y cubed is going to move. I'm going to have to divide it this time, and it's going to go to the denominator on the left. This 1 plus y to the 4th, since it's in the denominator, I'm going to have to multiply it to put it in the numerator on the left. Now this dx needs to move to the right with all the x's. Since it's in the denominator, I'm going to multiply both sides by dx to put it in the numerator on the right. So ultimately what I get is 1 plus y to the 4th over y cubed dy equals e to the 5x plus 1 over e to the x dx. All right, so variables are separated, check. So now we're going to integrate both sides. Now, before we integrate, I'm going to clean this up a little bit and just simplify this a little bit. So on the left side, I have a single term denominator, so I can break this up as 1 over y cubed plus y to the 4th over y cubed dy. And on the right, I have e to the 5x over e to the x plus 1 over e to the x. And then it simplifies to, on the left, y to the negative 3 plus y dy equals e to the 4x plus e to the negative x dx. All right, so now we're ready to integrate both sides. So on the left side, we're going to just do reverse power rule. So we add 1 to the power, divide by the new power. So we get y to the negative 2 over negative 2 plus y to the positive 2 over positive 2 equals. Now on the right side, I'm going to do a mental u substitution because my inside function 4x is linear. So when I do the chain rule with the derivative, I will multiply by 4. But since I'm doing the antiderivative, I'm going to multiply by 1/4. So I'm going to get 1/4 e to the 4x. And then similarly, I'm going to multiply by negative 1 for this second term. So I get negative e to the negative x, and then my plus c. So now I've integrated both sides. And so now we're going to use our initial condition now to solve for c. We were told that y of 0 equals 1 over the square root of 2. So I'm going to plug in 0 for x and 1 over root 2 for y. Now, wouldn't it be nicer if I just had positive exponents, right? I like to stay positive in life. So I'm going to go ahead and first rewrite this left side. So my first term is going to be, I'm going to move the negative to the numerator. The negative exponent will go to the denominator with the 2. So I'm going to have 2y squared plus y squared over 2 equals 1/4 e to the 4x minus e to the negative x plus c. All right, so now I can plug in. So I'm going to get negative 1 over 2 times 1 over root 2 squared plus 1 over root 2 squared over 2 equals 1/4 e to the 4 times 0 minus e to the negative 0 plus c. All right, so notice here I'm squaring 1 over root 2 squared. And I'm just going to notice here, right, 1 over root 2, if I square that, I just get 1/2. So this is going to turn into negative 1 over 2 times 1/2 is just really going to be 1. And then plus 1 over 2, so it's going to be 1/2 divided by 2, which is going to be 1/4, which equals 1/4 times, the exponents here are going to be 0, and e to the 0 is just 1. So 1/4 times 1 minus 1 plus c. So I got negative 1 plus 1/4 equals 1/4 minus 1 plus c. Well, I like that because I can cancel the 1/4 on both sides. Negative 1s cancel as well from both sides. So this tells me that my c value is actually 0. So that's cool. So then now we go back to this step where we plugged in to find c, which was right here. And we're going to work from there. So I'm going to go ahead and copy and paste this. All right, I got my problem here on the right side just to keep in mind what we're going for. All right. So now I'm going to go ahead and just erase c since we know it's 0. And then move this over a little bit. All right, so then now we were told that we were trying to figure out ultimately what is y of log base e of 2. So log base e of 2 really is the same thing as the natural log of 2. So I'm going to write it as y of ln of 2. So I'm going to just substitute in ln of 2 for x and see what happens and see if we can solve for y. So I'm going to really just leave the left side unchanged right now. So I'm just going to rewrite it. On the right side, we have e to the 4 ln of 2 minus e to the negative ln of 2. All right, now from algebra, I know my properties of logs tell me that if I have an exponent or if I have a coefficient in front of a log, it moves up into the exponent. So I can actually rewrite 4 ln 2 as ln of 2 to the 4th, which is just ln of 16. And I can rewrite negative ln of 2 as ln of 2 to the negative 1, or ln of 1/2. So then my right side becomes 1/4 e to the ln of 16 minus e to the ln of 1/2. And the left side stays the same for now. All right, cool. Now, we also know that e and ln are inverses, so they cancel each other out. They undo each other. So the right side simplifies to 1/4 times 16 minus 1/2. All right, so we have negative 1 over 2y squared plus y squared over 2 equals 1/4 of 16 is 4 minus 1/2, which is 8/2 minus 1/2, which is just 7/2. All right, so my equation now is negative 1 over 2y squared plus y squared over 2 equals 7/2. All right, cool. So now we just got to solve for y. So now at this point, I'm going to make a common denominator on the left side. So I notice that my common denominator needs to be 2y squared. So this second fraction is missing a y squared. So I'm going to multiply denominator and numerator by y squared. So then now combining these two fractions, we get negative 1 plus y to the 4th over 2y squared equals 7/2. So now, different ways you could do it. You can cross multiply on both sides. You could multiply both sides by 2y squared to clear the denominators. I'm going to do that, but it's just preference. So that clears. And then these 2's clear here. So then we get negative 1 plus y to the 4th equals 7y squared. Now I smell a quadratic because I'm seeing this y squared and this y to the fourth. So I'm gonna write this in standard form and move this term to the left side and set it equal to 0. So I'm gonna get y to the fourth minus 7y squared minus 1 equals 0. Oh yeah, I definitely smell a quadratic because if I let u equal y squared, we know that y to the fourth is really just y squared squared. So this is going to be now in terms of u squared minus 7u minus 1 equals 0. Yeah, this is definitely a quadratic equation and we can solve. So I'm going to now move this down here. We on page 3, y'all. All right, so this cannot factor, but we can solve it with the quadratic formula. So I'm going to say that u equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. All right, so u equals 7 plus or minus the square root of, the radical inside is going to be 49, and then those two negatives make a positive, so plus 4 all over 2. So u equals 7 plus or minus the square root of 53 all over 2. All right, so 53 is prime, so this square root can't be broken down any further. But let's write this in terms of y because we want to solve for y. So we said that u was y squared, so we're now going to replace u with y squared. So y squared equals 7 plus or minus the square root of 53 divided by 2. Now to get y, we need to undo this square by taking the square root of both sides. Now anytime we take the square root of both sides, we need a plus or minus. So on the left side now we have y equals plus or minus the square root of 7 plus or minus the square root of 53 divided by 2. All right, we're getting close. Now, here's the thing. We need to resolve the plus or minus here, both plus or minuses, right? Now, the thing is, though, I noticed that the square root of 53, like 53 is bigger than 49, right? Which means that 49 is less than 53. So that means that the square root of 49, which is the same thing as 7, is less than the square root of 53. Now, I care about that because anything that's underneath a square root has to be positive. So if I do 7 minus root 3 or 7 minus root 53, since 7 is smaller than root 53, this difference is going to be actually negative. And I can't have a negative underneath this radical. So I'm actually going to reject this negative branch and just really take the positive portion underneath the square root. So this is going to give me y equals plus or minus the square root of 7 plus the square root of 53, all divided by 2. Now we need to resolve this plus or minus on the outside, right? Because I can't have two values for y because I have to have a function. Now remember they told us that y was a function that had a range of 0 to infinity. And remember we see the initial condition was also positive? Yeah. So that tells me that my outputs need to be positive. So from that, I know that I have to choose, once again, the positive branch here. And that's because our range for our function is 0 to infinity. So our y value now is the square root of 7 plus the square root of 53 all over 2. So we're going to box that. And we're going here with choice B. All right, so that was an involved problem. That was a banger. So that was separating variables. That was algebra. That was quadratic formula. Dealing with square roots and range restrictions and domain restrictions. So that was a lot packed into that question, but I thought this was a really, 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 really dope question. So shout out to Math Scribbles for this one. Stay tuned for more problems, and I'll catch y'all in the next video.